Hi everybody, this is Miss McClellan here to go over our IM2 Checkpoint 3.1 practice version. The first topic is basic probability. You go trick-or-treating. Here we are. We're going to find these probabilities. Suppose house 1 has 1/5 Sour Patch Kids, 2/5 jelly beans, and 2/5 toothbrushes. Whereas house 2 has 2/3 Snickers and 1/3 peanut M&Ms. What is the probability that you get some Snickers? Well, that probability is 2/3 because you're definitely going to both houses. And so 2/3 of the time you'll end up with some Snickers. 2/3. And the probabilities the probability that you don't get Snickers, well, that would be 1 minus 2/3, which is 1/3. The probability that you get both Snickers and jelly beans, I'll do this in a color, and let's find Snickers and jelly beans and where they interact. Okay, you have a 4/15 chance, 4 out of 15 chance probability of getting both Snickers and jelly beans. I'll do that in black. 4/15. And what is the probability that you get Snickers or jelly beans? Well, for that to happen, you could get anything in any of these 4 boxes. So, to figure that out, you'd have to add all of these up. 2/15 plus 2/15 plus 4/15 plus 4/15. This is method 1. I'm going to do 2 methods. And that equals 8, 10, 12/15, or 4/5. Let me do another method here, because there's more than one way to do this problem. The other way would be to add probability of Snickers and the probability of jelly beans, and then subtract their intersection. Which would equal 2/3 plus 2/5 minus 4/15. And if you do that, you again get the same answer. Okay, next, we'll show our calculations and we're going to find these probabilities. X takes up 1/4 of this circle. The probability of spinning X is 1/4. You could also figure that out by doing 90, because this is the 90-degree angle, divided by 360, the total number of degrees in the full circle, and that equals 0.25, which is the same as 1/4. I would take 1/4 or 0.25. Okay, part B, the probability of spinning X. Well, this is a 51-degree angle, so you need to do 51 over 360. What's that equal? I'd like the answer this time as a decimal, because I don't know very many people who can really visualize what 360 means. Okay, this is 0.14. And the probability of spinning Y, well, that's everything except for X. So that will be 1 minus 0.14. which is 0.86. We continue. We're on the second topic now. This topic is independence and sample space modeling. For the spinner in problem 4 below, so we'll look down here, are the events spinning blue on the first spinner and spinning green on the second spinner independent? And we need to reference the definition of independence in our answer. Okay, well, yes, they are. They are independent. I know because the spinners do not interact with each other. So the probability of spinning blue on first spinner is not affected by the probability of spinning green on the second spinner, or vice versa. Vice versa just means the opposite is also, the converse is also true. Spinning green on the second spinner does not impact spinning blue on the first spinner. Okay, now we'll do number 4. Number 4 says to draw an area model or tree diagram to model the sample space. I'm going to do an area model. Either would work because I have 2 events. Okay, spinner 1, spinner 2. Spinner 1 could be green, blue, or red. Probability of green is 3/8. Probability of blue is also 3/8. Probability of red is 1/4. Spinner 2 could again be green, red, or blue. Probability of green this time is 1/4. The probability of red is 1/4. The probability of blue is 1/2. Okay. Spinner 1 is first, so I'm going to put all of the spinner 1 letters first. So R, R, R. Blue, blue, blue. Green, green, green. And let's be clear, this is R1, blue 1, blue 1, blue 1, green 1, green 1, green 1. And then I'll do these. This is G, 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 and these are all for spinner 2. Red, 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 and these are all for spinner 2. Blue, blue, blue. These are all for spinner 2. And to find the interior numbers, I'll be multiplying the exterior probabilities. So this is 1/4 times 1/4 equals 1/16. This is 1/16 again. This is 1/4 times 1/2 equals 1/8. This is 1/4 and 3/8, so this is 3/8 times 1/4 equals 3/32. This is 3/8 times 1/4 again, so that's going to be 3/32 again. This is 3/8 times 1/2, so that's 3/16. This is 3/8 times, oh, it's the same as above. So this is 3/32. This again is the same as above, so it'll be 3/32. And this one will be again 3/16. And that's my area model. Bada bing. Now, number 4 says probability that you spin B on spinner 1. So I want to find the probability that spinner 1 is B, so B1, and G on spinner 2. So what does this equal? Okay, I want B on spinner 1. So it could be any of these. And I want G on spinner 2. So it could be any of these. And I want them both to be true at the same time. And the only one which allows for that to be the case is this one right here. So this answer is 3/32. Bada bing, bada bing, bada boom, all done. Okay. Be careful with your notation in this problem though, because I do want you to have P and then parenthesis, what you're finding the probability of, close parenthesis, equals the probability. Notation is part of your grading rubric for this problem. Okay, next page. This topic is expected value and fairness. What is the expected value for the spinner? Well, the definition of expected value is that you take each outcome and multiply by its probability and then add those results together. So let's go ahead and do that. The first outcome will be that you land in this region. So we'll do the probability of landing in the region that gives you $5 times 1/4. Oh no, sorry, it is 1/4. I should say $5 could happen 1/4 of the time. Add that to $1 should happen also about 1/4 of the time. And $2 should happen 1/2 of the time. So I add all of these up. I have, on my calculator, I'm just putting it straight in. 5 times 1/4 plus 1 times 1/4 plus 2 times 1/2. Enter. And that gives me $2.50. So if I play this game and it doesn't cost anything to play it, the expected winning is $2.50. And then based on the definition of a fair game, if I have to pay $3 to play, is it fair? And no, because if that's the case, then I would expect to not break even. $3 does not equal $2.50. Remember, in order for a game to be fair, the cost must equal the expected value. Let's just write that in there. In order for a game to be fair, cost should equal expected value. Period. Okay, suppose the expected value of the spinner is $4. Solve for x. So this time I start knowing what my equation is going to equal. So I have $2, and that'll happen about half the time, plus X dollars, and that will also happen about half the time. And I know that this is going to equal $4 because I told you the expected value is $4. So this becomes 1 plus 0.5x equals 4. I subtract 1 from both sides. I have 0.5x equals 3. I divide both sides by 0.5. And that gives me x is equal to 6. So x is $6. Okay, lastly, we have the spiral review comment. Your actual checkpoint will include a spiral review section. Practice problems for the spiral review are basically just your homework. So make sure you do your homework. Try to understand all of the review problems in your homework because they're all fair game. Hope you have a great day. Thanks for watching, and I'll see you next time. Bye.